Okay, what is a derivative? A derivative is just the rate of change, which is also just the slope, right? So if I have a graph, you see that? All right. Graph, it goes like this. I can find the derivative of each point by taking the slope at each point. So to find the slope at each point, I'm just going to make tangent lines. So for this point, it's like that. For this point, it's like that. This point, like that, and like that. So the derivative at this point, just say, let's make it x equals 1, is probably about 2, depending on your scale, because you're just taking the slope of the tangent line right here. The derivative of x equals 2 is probably negative 2, because the slope of our line right here is going down. And the same thing for just say x equals 3. Probably about 3 or 4, whatever the number is. The derivative is just the rate of change. So, to make it a little more simple, if I take a plot like this, okay, just a straight line, right? Y equals x. 1, 2, 3, 4. So, if I take the tangent point, or this tangent line at x equals 1, I'm going to draw a little tangent line right here. What's the slope of that line? The slope of that line is 1. I'll do the same thing at x equals 2. What's the slope of that line? The slope of that line is 1. X equals 3, same thing. Slope of that line is 1. So, if I want to find the derivative of that whole function, I can plot what the slope is at each of those points. So in this case, at x equals 1, the slope is 1. So I'll put 1. At x equals 2, the slope is 1, and 1, and 1. So the derivative of y equals x is just y equals 1. Okay? You also could say that y prime is equal to 1. Y prime just means that it's the derivative of y. You could also say this is the function of x is equal to x, f prime of x equals 1. Now, let's do another example. If I say we'll do a quadratic, right? So we have 1, 1, 2, 2, 3, 9, 2, 4 actually, 3, 9. Okay. If I take the slope of this point right here, it's rough, but it's probably 1. If I take the slope of this point right here, it's rough, but it's probably 2. If I take the slope of this point right here, it's rough, but it's probably 3. You can do this on graph paper and it'll be much neater. But so my function here is y equals x squared. So if I go over and plot my derivative of y equals x squared, at x equals 1, the slope was 1. At x equals 2, the slope was 2. At x equals 3, the slope was 3. So I can make that line. What's that function? That's just y equals x. Actually, it should be y equals 2x. But you get the idea. You're just plotting the slopes. So y prime equals 2x. F of x equals x squared right here. F prime of x equals 2x. So that's the idea of a derivative. It's just the slope of the line. So a more physical example is when you have a position function. So let's say our position function is f of x equals, we'll say, x. Okay, same thing what we had up there. Okay, it's just a straight line, 1, 1, 2, 2, 3, 3, 4, 4. Okay, well, we did this earlier up here, and we see that the derivative of that is just 1. This is the velocity. Actually, usually they do this with t's. So x of t usually marks position. And we'll say v of t is the derivative, velocity is the derivative of the position equation. So the position equation is just x. We found up here that the velocity equation, or the velocity equation for this would be 1. So v of t equals 1. So the velocity is the derivative of the position. Now, you can go one step further and take the derivative of velocity. The derivative of velocity is acceleration. So if I take the derivative of velocity, I can go through and do my same thing, make a bunch of tangent lines, find the slope. Well, the slope of a horizontal line is 0. So my acceleration is going to be 0. So we'll say x of t equals x. So that's our position. And then we'll say our velocity, v, velocity with respect to time, is equal to 1. That's velocity. And then we'll say acceleration, a of t, is equal to 0. So you have a position equation. To get velocity, you take the derivative. To get the derivative, or to get acceleration, you take the derivative of velocity. Okay?